Hello student, welcome to our last lesson in this topic where we are going to look at application of total internal reflection. We start with the first one, the periscope. Now light is deviated through 90 degrees by the first prism before the second prism deviates it further through 90 degrees in the opposite direction. Now we have found periscope in form 1 when you looked at the application of the reflection of light. So we have the two prisms that are arranged at an angle of 45 as shown in this diagram. You can see that this one is at an angle of 45 this way and this way. So the object that is here, the rays that are coming from the top and the bottom of the object will be deviated by the first prism through an angle of 90. But on touching the second prism again, they are deviated by another angle of 90 degrees, but in the opposite direction. So you as the viewer, you are going to see a virtual image that is upright on this part. Now, when we are using the periscope, we use prisms and not plain mirrors because mirrors absorb some of the incident light, and number two, the silvering on mirrors can become tarnished and peel off. And also, thick mirrors produce multiple images. So due to these reasons, you find that prisms are used in periscopes instead of mirrors. Then from there, we move to the second application, which is optical fiber. Now, this one is a thin, flexible glass rod of smaller diameter. And the diameter can be smaller in the order of 10 to the power negative 6 meters. Very small. Now, the central case of the glass is coated with glass of lower refractive index, and this process is called cladding. So when you are told to define cladding, you should be able to know that it is the coating of the central case of the glass of optical fiber with the glass of lower refractive index. We have it here. We have the inner core here. Then we have the cladding. And remember, the ray will be passing through inside here, as we are going to see. So this one, although in our diagram is appearing to be a big fiber, you should note that it is very thin. But now we have enlarged the image so that you can be able to see the parts. Now, when a ray enters the fiber, it undergoes total internal reflection on the boundary of the higher and lower refractive index until it travels the entire length of the fiber, which implies that the light will travel throughout the length without any getting lost. We have this as our diagram here. We have the transmitter that is giving us the signal. We have the cladding. I hope you're going to get it clearly here. We have the cladding on this side and this side. And cladding ensures that we have a low refractive index here and here. But in here, we have a higher refractive index, which implies that the ray that is entering will be coming from optically denser medium to less optically denser medium. And that is why now we have at this boundary, there is total internal reflection. So that ray will continue with the total internal reflection until it emerges on the other end here. So that way we are saying that that ray will move without any getting lost. Then from there, we need to look at advantages of optical fibers over ordinary cables. Now, one, they have a higher carrying capacity, and number two, they are thinner and lighter. Then we look at the uses of optical fiber. One, they are used in medicine to view internal organs of the body. And number two, they are used in telecommunication where they have a higher advantage than ordinary cables. When we talk of ordinary cables, we are talking about the copper cables and any other cable. They have an advantage because they have a higher carrying capacity, and again, they are thinner and lighter. Then from there, we move to the dispersion of white light. Now, dispersion of light is splitting of white light into its component colors. What you need to understand here is that white light is a combination of 7 colors of the rainbow. And when we split and separate them, then we have what we call the dispersion of white light. Therefore, the components of white light will travel with the same velocity in vacuum, but different velocities in other media. And due to these different in velocities, as they move in other media, then you find that they will be separated, as shown in this diagram. You have that a white light is coming from the source, moving with the same velocity, and therefore you can't even notice their components. But as it touches this interface, the velocity changes and there will be refraction. Remember, initially we said that refraction occurs due to change in velocity. Now, as the velocity changes here, for different colors, the velocity is different, and that is why they are deviated differently. And by so doing, we have separated the 7 colors of the rainbow, starting from the red, orange, yellow, green, blue, indigo, and violet. Now, the causes of dispersion of light are due to the different velocities in given transparent media. In other words, we are able to separate the components of the white light because those components or those colors, they have different velocities in a given transparent medium. And as you can see, the velocity of red is highest while that of violet is least, which implies that the red color has the longest wavelength because we are using this formula, the one that we call the wave equation, where velocity is equal to lambda frequency. So it implies that if the velocity is high, then the wavelength is high. And if the velocity is small, then the wavelength is small. That is why now we are saying the violet has the least wavelength. Then from there, we have the rainbow. Sometimes we see the rainbow when it is raining, but we need to understand where does it come from. Now again, the formation of rainbow uses the total internal reflection. And rainbow is a bow-shaped color, but of visible spectrum seen in the sky. If you are very careful, you'll find the 7 colors when you see the rainbow. So it is bow-shaped color band of the visible spectrum seen in the sky. And this one is formed when the white light from the sun is refracted, dispersed, and totally internally reflected by the raindrops. This happens when there is sunlight and there is rain. And this is what happens. The ray of light is coming from the sun. This is a water drop. Remember now, the water drop will act as a prism. As it strikes this interface, it will be refracted because there is change in refraction. There is change in velocity. So in here, there will be refraction. But as it moves towards this other end, now the angle of incidence will be greater than the critical angle, and we shall have a total internal reflection. The same case applies here. There will be a total internal reflection. And as it happens here, because of different velocities, you will find that the rays, as they emerge from this side, they will be separated, as you can see here. As they entered here, it was just a single white light. But due to refraction here, there was a separation or the dispersion of white light. We have red and violet here. As they are totally internally reflected again, they are the 7 colors of the rainbow that are being reflected here. Again, as they are refracted outside here, they will appear as the 7 colors of the rainbow. So that is how the rainbow is formed. So we as the viewers on the ground, we see the 7 colors. Then from there we have the assignment. Again, the assignment is testing what we have just learned. So make sure that you approach it with a positive attitude and also prepare for the end of topic exam. Thank you, and let us meet in another lesson or in another topic.